what's up guys? Got another inverter today. It's a 150 watt BYGD. This one's kind of like, from the listing it looked like the Ferrari of cheap inverters basically. It's all decked out, you know, Ferrari red, you know, rotatable, you know, cigarette lighter plug. Well, I mean, all of them are rotatable. Well, I'll show you in a minute, but let's get this bad boy open and see what we got, do some testing, and see if maybe it blows up. Really want one to blow up, but I don't see that happening. They're just gonna get really hot, and we don't need instructions where we're going. Alright, so let's take the little sleeve off of that boy. As you can see, it is definitely the race car of cheap inverters. It is light. There's nothing to it. I don't know if I can. All plastic. So no aluminum here for heatsink. Oh well, we'll find out when we break it open. But it does have two USB ports. These are 2.4 amps a piece. And then we have the most unnecessary amount of plugs here for a 150 watt inverter, which I get it. You could like plug in multiple, you know, devices like laptops or, you know, these, but guess what? You already have these. You can add another one if you want, but you can plug in multiple laptop chargers, or you can plug in, you know, let's say you have a Ryobi charger or a Milwaukee charger, all at the same go. I don't know how many watts those pull. I mean, I guess I could try and test one and see what it does, but I'm not doing that right now. I want to see if this bad boy blows up. So let's get right into it. So what I'm gonna do first is plug this thing in, and then let's see. Oh yeah, she's got a power light right there. Let's see, let's turn the oscilloscope on. Get this bad boy going. Alright, she's fired up. I'm fired up. Let's get this thing going and see. Oh, well, you already know it's a modified sine wave. Can't get that lucky to find one of these ones that, I mean, they don't even list and tell you if this is modified or, you know, pure sine wave. So it's a gamble, I guess you can say, but I already knew it was most likely to be modified sine wave for being that cheap, 100%. So basically, what I'm going to do next is start testing the USB ports. Let's see if they actually handle 2.4 amps. Let's make sure I ain't got this thing bumped. And I did. So, USB port 1, we got 5 volts for sure, and then let's pump some amperage into that. Oh wow, it like, I don't know, maybe it's just me, but okay, yeah, that was just the oscilloscope backed up. Alright, so I got 2.5 on there just for testing sake. And it's handling it ish. So let's move on to the other one. I'll leave it at 2.5. There we go. She's in there. And the crazy part is the sine wave keeps changing. I don't know if that's normal, but I can auto set. Let's see again. Okay, no, it's just changing it on its own. It's got a mind of its own. Also a cheap oscilloscope, but it does what it needs to do. It's actually pretty damn good at it. So what we'll do is unplug this and move on to actually testing this thing. And I can actually do it with the pure sine wave. So, alright, that bad boy. I said pure sine wave. I mean with the light. Alright, so that's plugged in. And I need to figure out a way to actually show this one. Oh wow, okay. I know the first thing y'all are gonna say is, oh no, you're covering the fan. Yeah, the fan is right here. So at first I thought it was at the end here, but no, it is right there, and it does move some air. So maybe this one might perform pretty damn good. So, oh. Alright, we know that works. Take a pause for a second. I'm going to set you guys up with the watt meter and the, which is, it's on its side, so I mean I guess I can flip it when I get in editing mode, I guess. But let's see, let's get this going. Alrighty, we're going to start the test now. I'll get the, let's see. What I'll do is go ahead and move that right there. Now you can see the wiring all one shot, and I'll go ahead and get this ball rolling. You can see how fast. And I bumped it back down. You can see how fast that wire heats up. And it'll go down eventually as well, the wattage will. Usually as the bulb heats up, the resistance goes down. So I'm gonna let this sit for 5 minutes. And if you look at this clock right here, that clock, you should be able to see the time. And let's go. Alrighty, it cut off. Nice. Alright, couldn't even handle 140 watts in a long period of time. Alright, so, but it's still running, so it didn't blow a fuse. So, that's what I expected. I didn't think it was going to last very long. I don't see no heat sink anywhere. I guarantee they just got the fan blowing over top of the MOSFETs. So I'm gonna go ahead and move on to tearing it down, and let's see what's inside. And I'm sure she's hot. Yeah. Like I said in the last video when I tested those other two, I hate to say it, but the inverters are working, but the wiring is getting hot. Now, I say they're working, the inverters are working, but this one was, I mean, it dropped down to 140 watts and it was still, well, it still freaking went out. So, there you go. So, I'm going to move on to tearing that bad boy down. Alright. Let's take this thing apart. Finally. And this thing isn't even hot. The wiring is, but this is not. So it tells me that I don't know if they're using just cheap wiring in these things. I know for a fact they're not using the proper gauge of wire, because I guarantee if I cut this open, there's probably maybe like 20 strands of copper wire in there. So, not enough. There's too much resistance here, and it's causing too much heat. Which, you know, if you're making an inverter in a budget, well, on a budget to sell for cheap, I mean, you're not gonna spend a crap ton of money to make it so it's 100%. Most people aren't gonna, you know, contact whoever to return these things. If they don't work, they're gonna be like, "No, it's $15. It's not worth the hassle," and that's what they're banking on. But they're also not banking on people going out and testing these things and telling people not to buy them. So, which I'm sure, you know, it even says it right here, Bob. Caution reads instruction manual. It probably tells you a bunch of hoopla, you know. The inverter may get hot, which, I mean, it's covering their butts, which makes sense. We're gonna get this bad boy taken apart. Maybe that's all the screws, but I mean, this thing's built just like a surge protector. Like it was made as a surge protector and they modified it. Like, in all seriousness. That's what it looks like. I mean, it looks cool, I guess. Oh, wow. There's a lot more to do. Wow, look at them ugly solder joints. Ew. I'm going to show you that. That is repulsive. It is not good. This one, these two right here are the worst. And that's where the power goes in. Or the 12 volt power goes in. And then you got this little resistor, I guess they took off or whatnot. Is down here is janky. But let's see, I put you back right here. There's the 12 volts, and that is just spliced back down there. And then this is small. This is the tiniest one I've seen so far. As for, you know, the PCB anyways, for the inverter side, that explains why it cut out. If you hear a fan running right now, it's because I actually got the charger on this thing. Just to give it a good old wow. Okay. Alrighty. This is janky. Alright, so let me show you how they did this. And of course the wire management here is not very good. I'll go ahead and unplug that. Just so I can get it out of there. I don't feel like taking all this off. Okay, so they do have heat sinks on this thing, but look at how they do it. And that's just not what you want to see inside of an inverter. But look at, if you look, the three sockets, there's the wiring for the 3 sockets. And it almost looks as thin as this right here, which was for the fan, I believe. You could use these 12 volt fans, I guess. I never have these things. But yeah, look at that. That's what they use. And they're not hot, but that is crazy. And then they glue, it looks like they glue a temperature sensor on it, which is probably, this got too hot, and then a temperature disconnect kicked in, and basically said, no, we're not running no more. But yeah, they put the fan right here, and there's no airflow through here. So I mean, there's nowhere for air to go. I mean, I guess it's got a grate on the back side there, but and then you have the board back here, which is guaranteed just for the USB stuff, and it's probably just a step down board for 5 volts for the USB. Yeah, to me this thing looks like it was probably a which you can take this thing. Oh, there we go. Yep, that's what it is. It's just a USB board which you can wire 12 volts to, and which you can use for something else, I guess. And that's just a little board, PCB. And look, man, they didn't even bother cutting. They didn't even bother cutting. Yeah, somebody was in. That was built on a Friday right before beers with the boys. So I don't know what they do in China, but you know, I imagine they get to go out and hang out with the boys every once in a while. But yeah, that's another cheap inverter that I would say I'd never buy, but you know, obviously I did. But you guys, don't buy this junk. And I'll have a couple other ones. Buy something that's, you know, rated for more. 500-600 watts. Make sure it's pure sine wave. I can keep saying it all day, but I still have fun doing this and taking it apart. I hope you guys enjoy watching these videos. I know I enjoy making them. I just noticed that this is broken, but I hope you guys enjoy. Like and subscribe. I'm going to be making more and more of these bad boys every day. I actually got some vintage ones coming, so stay tuned for that. And enjoy the rest of your weekend, because it's Saturday and it's freaking early. But I get up this time normally on a weekday. So have a good one.